homework review session. If you have homework questions, we'll work on them. That's pretty much it. So if nobody has any questions, what I did have up was the next workbook assignment. It's 6 questions, and they're due the following Friday, not this Friday, the following Friday. If nobody has any questions, I'll probably just work through those 6. If you're here, you're here. So, but other than that, does anyone have any questions for me? Again, make sure you have the workbook assignment jotted down. If you don't have any questions for me, I'll probably just start working through those 6. I might just pick random problems from the homework until time expires. But any requests for any homework problems? So if not, okay, Molly, hang tight. Yeah, for those of you just joining, go ahead and write down the next homework workbook assignment. Do the following Friday, not this Friday. Well, while you're finding that problem, I'll just do the first one from the workbook just to fill some time. And then after that, you can ask me what your question is. Okay, so I'm going to do the first one from the workbook assignment. And it simply wants us to find the solution for the square root 3t plus 4 equals to 2. So all the solutions of t that satisfy that. And we've done problems. We did a problem fairly similar to this in the notes. So this pertains to a problem from the section on radical equations. So what did we do first? What we did, I'm just going to rewrite the problem. Since the radical is isolated, we went ahead and got rid of the radical by squaring both sides. So this is a square root, and we're going to square both sides. So square and the square root cancel. Left with 3t plus 4 is equal to, well, 4. And Molly, I'll look at your question after I'm done with this one. So from here, well, we just go ahead and combine like terms. The 4's go together to give us 0. So if you move this 4 over here, 4 minus 4 is 0. And so we get that t is 0 after we divide 3 on both sides. So technically, we need to check our answers. So if you plug in to check, this would be the square root of 3 times 0 plus 4, which is just square root of 4. And that's 2. That's it. So it works. Because I plugged in 0, and the equation at the very beginning is still true. So there's 1/6 of your workbook assignment right there. Now, Molly, I think it might be easier. Actually, I think I can dissect that. So I think what you were asking, and as you all request problems, it would be easier for you to just tell me the problem number from the homework. I could find it a lot more quickly. But I think what this one is a substitution problem. Okay, so for those of you following along, this is problem 11 from the homework. X plus, and it looks like the square root of that exact same thing. Now, 1 second. I feel like we did this problem. Maybe we didn't. Okay, so we did this problem actually in the notes, and I could do it again, but we did almost exactly this problem in the class notes. I can go through it again. It's a kind of tricky problem. So that's fine. So let me go ahead and get that set up. Oh, okay, you got it? Then, all right, that's fine. If anybody else wants me to work it out, just let me know. But yeah, we, that problem 11 from the homework, I did do that in class. So you can reference that in the video I posted. So, cool. So, so we're gonna just avoid that one. Let's avoid that. Does anyone have any other requests? Any particular problem? If not, I could just keep going through the workbook assignment. So I guess while I do this, I suppose while I do this, you can go look up some examples or some example you may want me to do. I'll look at problem 2 from page 13, just the next workbook assignment. So this is the next one I assigned. It's fairly similar. You have the 4th root of 3t plus 4, so same radicand, just different roots. Instead of a square root, it's a 4th root. And it says that this is equal to negative 13. I wonder why this is a nice problem. Do you have any clue?
It's a negative. It can't have negative.
Yeah, the 4th root cannot output a negative. So, really this problem is just a dud problem. fourth root cannot output a negative. This problem just has no solutions, and that's it. Okay, cool. So you would just say no solutions, and that's it. That's the whole problem. So square root, it's the same principle. Square root also cannot output a negative. But if we had a third root, that would be okay. A third root isn't picky. So if this was a third root, we'd have to work this problem out. If you did work this problem out and you couldn't remember this rule, then at the very end of the problem, you would get a solution. And when you plug that solution back in to check your answers, it wouldn't work. So if you did not remember this rule, then you would end up hopefully finding out that the solution you found is not good. But if you can find it at the very beginning here, then it saves you a lot of time. So that's problem 2. It's just genuinely no solutions. That's all the work there is for this one. Well, any homework questions, or should I just keep going? If I've run out of workbook assignments, I'm just going to go into the homework and pick ones that kind of look tricky. I don't mind. Try problem 4. Okay, number 4. X squared minus x minus 4 is equal to x plus 2. So again, this is another radical equation problem because, well, there's a radical. So what do we do in radical equation problems? Generally, the first thing we try to do is isolate the radical. Well, this problem, it's already isolated. So step 1's already done. What did we do next? We get rid of the radical. This is a square root. You get rid of a square root with a square. So I'm just going to rewrite it. So I can emphasize that we'll now apply a square to both sides to get rid of the square root. The square root and the square cancel. You're left with x squared minus x minus 4 is equal to x plus 2 squared, which we will have to FOIL. I'm going to write down x plus 2. So we're going to go ahead and FOIL this. X squared minus x minus 4 is equal to, well, when we FOIL this, x times x is x squared, plus x times 2 is 2x, plus 2 times x is another 2x, plus 2 times 2, which is 4. We can go ahead and combine these two middle-like terms. This 4x. 2x plus 2x is 4x. And now we can combine more like terms. And subtract x squared on both sides. which really just cancels out the x squareds. We can add x on both sides. We can add 4 on both sides. So that's going to be 5x plus 8. And so subtracting 8 and dividing by 5, we just get that x is negative 8 over 5.
We need to check that.
Yes. You would need to check this. So for this problem, I mean, really the reason why you don't have to be too meticulous about checking this one is because there's a certain pattern here. Since there wasn't an issue in the beginning of the problem, there's not going to be one at the end. I mean, you can plug in negative 8 over 5 as well. It's kind of a hassle to plug into this whole thing. And I'll check it just for completion's sake. It's one of those things where the workbook problems are harder than the ones in my math lab, and you won't have to check situations like that. So this is what I'm trying to say. If we did check it, I'll check it just to be safe. Squared minus answer minus 4. On the left-hand side, I get 2 over 5. And on the right-hand side, I get 2 over 5. So it does work. So in general, you would have to check these, but what I'm trying to allude towards is that this is one of those tricky workbook problems where checking that's going to be a hassle. And you don't have to check it for the workbook, in other words. But in general, you would need to check these, which means you'd have to plug in that negative 8 over 5 or whatever number you get into every x to make sure that the left-hand side of the equation matches the right-hand side. If you really want to do it, you check. With the negative 8 over 5, you will get that 0.4 is equal to 0.4. After you plug in x, x is on both sides. So if you just want that practice, then there you go. But if anything, that is problem 4 from page 13 of the workbook. Does anyone have any questions so far? Oops, sorry. Oh, well, might be helpful for you two to be able to see the bottom of the screen. So let's do, how's that? Okay. I wouldn't imagine anyone has garnered any new questions about the duration of that problem, so I suppose I'll just go to the next page of the workbook. So in addition to those 3 problems, I also assigned 3 problems from page 14. I guess I'll just go through those unless someone stops me. So page 14, I assigned number 2. So for this one, really there's two ways you could do this problem. The way I would recommend, just for really for consistency's sake, is U substitution, but you may also use the radical equation method from the workbook. So you can either do these problems, or you can either do this problem using U substitution or radical equations. So I was thinking it's probably more recommended to use U substitution, because generally the middle term gives you a good idea as to what your U is. And then off to the side, to just confirm that this is a good choice, U is equal to the square root of X. What happens if you square both sides? Well, you get a square root and a square, which cancel, and you just get an X. So then you get that U squared is equal to X. Well, that takes care of this X right over here. So it works out perfectly. So now we have U squared plus U is equal to 20. And so we could subtract the 20 to the other side. So that way we have a quadratic in standard form, which means we can factor. And so we get two U values from this. We get that U is -5 and +4 after we flip the signs of the two factors. But with U substitution, these values are not good enough. Made a rule in the very beginning. Now, this is the new workbook assignment. Must have entered late. Now, this is the newest workbook assignment that I talked about at the beginning of class. So to get caught up with that, you'll just have to watch the video. So we have this rule that we will need to bring back. And from here, we will need to plug in both of our U values to figure out X values, because that's how we appropriately conclude this problem. So then we have, so one of the U values is -5. One of them is 4. Now one of these is it takes a lot less time to figure out the solution for one of these than the other. Do either of you two happen to see it?
Negative.
Yeah, negative with the square root. This one over here is pretty quick to determine that there's no solutions. Because a square root cannot output a negative. So there's no solutions for that one. It doesn't mean we're done. It just means we found the extra solutions. So we don't even have to check our answers at the end. But over here on the right, But over here on the right here, this is okay. And now to get x by itself, we can square both sides to get rid of these square roots. Square root with the square. And so all we get that is that x is 16. We don't really need to check this because we already got rid of the extra solutions or solution by being careful about the stuff on the left over here. So we only get one answer. And again, we don't have to check it because we already found the extra solution and we tossed it before we integrated it into our final solution set. So is that good? So I suppose I'll keep going. So the next one I assigned number 4, which just simply says 4x to the third is equal to 3x squared. Oops. Okay, so 4x to the third is equal to 3x squared. That's number 4 on page 14. So the first thing we need to do here is set this polynomial equal to 0 in some way, either by moving the 4x to the third over or the 3x squared over. Well, it would make more sense to move this term over here because we want the highest power term to stay positive. So the third power is bigger than second power. So third power term needs to stay positive. So the 4 needs to stay positive. So this is a subtraction. So this would be 4x to the third minus 3x squared. And now that's equal to 0, now that there's nothing left on the right. So now this is in standard form, which is good, because now we can start to evoke techniques of factoring, however that may work. Now, I noticed that both of these terms have something in common. Both have x squared in common. So we can factor out an x squared. So both have x squared in common, so let's think about what's left over. 4x to the third, we just took out x squared, so that would be 4x. And now minus 3, that's equal to 0. And then the reason why factoring is nice is because we can take each part and set that individually equal to 0. So the right-hand side, that's just a quick linear equation. Add 3 on both sides, divide by 4. For the x squared is equal to 0, all we have to do is take the square root of both sides. So generally that would evoke a plus or minus, but square root of 0 is 0, plus or minus 0 is just 0. So we get two answers. So that's it for problem 4. And I suppose we only have one more left. So let me just go ahead and knock out that one as well. Page 14, number 5. This one says x to the third minus 3x squared, 16x plus 48 is equal to 0. And hopefully this form elicits something in your mind that seems fairly reminiscent to something we've recently discussed. This is grouping. This is a grouping problem. How can you figure that out so quickly? There's 4 terms. 4 terms, you would instantly think grouping. So that's exactly what we would do. We would group these two and these two and hope that by grouping, which means factoring out from the dual terms, we would be left with an expression that repeats between the two groups. So with the first grouping that I have, they both seem to have x squared in common. So we can factor out x squared. We're left with x minus 3. So we better factor out something on the other problem such that x minus 3 remains. Now for that second group, if we were to factor out positive 16, then that would leave us negative x plus, well, 48 divided by 16 is 3. So notice it's off. So if we only factor out positive 16, we're off by a negative. Those two expressions left over in the groups are not the same. So this is what I was talking about in class. So that's why we need to factor out a negative 16. So that way, by factoring out the negative as well, it will flip the sign. So factoring out negative 16 from negative 16x would just leave us positive x. Factoring out negative 16 from positive 48, that's just a division. That's minus 3. And so there is our repetition. So this is exactly what we want to happen in grouping. So now x minus 3 is the repetition. What are we left over with? X squared minus 16. That's how the grouping works out here. And then now we have a factored form, which means each one of these can be set individually equal to 0. So one of them is pretty quick to figure out. Then the other one takes a second. But we get 3 answers. Don't forget, we take these square roots, which means we have to we have to induce the plus or minus. The square root of 16 is 4, so we get plus or minus 4. And besides for that, that is really all of the workbook 4 assignment that I would give. And so I'm guessing if you showed up late to class, you might not have the slightest clue what I'm talking about. At the beginning of class, I assigned workbook number 4, and I assigned 6 problems, which I just subsequently went through. I assigned that for October 2nd, which is not next Friday, but the following Friday, I hope. Yeah, so, but there's all 6 problems right there. So if you turn it in earlier, then fine. It doesn't matter. Other than that, and also since I have all of you here, I think only 5 students for college algebra have signed up for the remote testing through ProctorU. If I recall correctly, I got a lot more emails requesting ProctorU testing. You really need to get that done by tomorrow night. Because ProctorU, I sent out an email about it to everybody. So I didn't just send a selective email, I sent it out to everybody on the directions for how to sign up for ProctorU. I've already had people sign up with it, so I know the step-by-step process does work. You really need to get that done by tomorrow at midnight. By that point, ProctorU starts to charge a penalty for signing up late. However much that penalty is, I don't know. It's a ProctorU thing. So that's why you need to sign. If you're going to take the midterm through ProctorU, I figure I have a decent number of you in here right now. So if you're signing up through ProctorU, you really need to make sure you do that by tomorrow night. This is just imperative. This isn't something you want to wait on. So, and again, I sent out an email maybe a few days ago. Yes, Caitlin. So for those of you who have had 105 or maybe 151 before, the test is going to be in the map lab where the tutoring hours would be at. Yeah, so you would take the test there. For those of you familiar with that. For those of you not familiar, we are not taking the test, of course, in class. There's no computers in here, so that wouldn't be too helpful. We're taking the test in the library. The room number I did specify in the email, Sims Library, room 208. And you will take the test in person based off of which group you are in. Mainly, this is by your last name. You have a last name that's, I think, G and higher. I can't remember offhand. That might be for a different class, but if you have a higher up last name, if you're higher up alphabetically, then chances are you'll be taking it Monday. And then lower alphabetically, you'll be taking it Wednesday. I'll talk more about this on Friday as well. So, yeah, Friday, and yeah, as I mentioned, Friday is going to be a midterm review session. Normally we have 50 minutes for that class session, but I figure if you want to stick around, I'll just keep working out problems until my next review session for my other section. So that was quite a bit of information. And if you need a refresher on that, you can always just check out the video when I post it. But you have a question?
Yeah, is the midterm cover 1 and chapter 2 or just chapter 2?
So the midterm covers, so I think it says it I think they have it in the syllabus somewhere. In fact, that's a good question. Let's take a look.
I went through emails trying to find it, but I wasn't sure.
The midterm, it's 2/3 from what we've just, from everything after the first test. So chapters 1 and all that stuff. And then 1/3 from unit 1. So that is how the midterm will be, I guess, distributed in terms of quantity of questions. So, and yeah, it is 70 minutes. If you are, I forgot to mention this, if you have accommodations, then if you have accommodations, and I don't know if you need a specific accommodation, but you may take your test in the testing center, which is not, you take it off, you take it somewhere else in a quiet environment, all that stuff. You don't take it through ProctorU, you don't take it in the math lab, nothing like that. You take it in the testing center, and you have to schedule an appointment with them on your own. If you need help doing that, just shoot me an email. I've already had a few people ask me. It's fine. It's pretty straightforward. I can help you out with that. So if you have accommodations and you can take a test, and you're taking the test or are accommodated to do so, then you need to get that. You need to reach out to them and get that done ASAP. What else? Oh, and I guess the big thing is we don't have class next week. I think that's a pretty big deal. So the whole week is just dedicated to the midterm. So all you do next week for this class, well, you could turn in the workbook on that Friday if you want. If you turn it in, if you turn it in by tomorrow, then all you have to do next week for this class is the midterm. There's no class. I'm not lecturing. There's no class next week. So hopefully that gives you a bit of time to focus on other things. So no class next week. ProctorU midterm testing, please sign up for that as soon as you can by Thursday night. And 70 minutes, I think I remember seeing 17 questions on the midterm. I think there's 17. Again, the distribution of the questions, 2/3 from linear equations up and 1/3 from everything we started off the semester with. So anything else I need to clarify, or should I just look at some homework questions? So just look at some homework questions. So you have to use ProctorU if you want to take the test remotely or not in person. If you want to take the test in person, then you'll show up at the time that I emailed you about at the Sims library. But if you take the test remotely, so that means you don't take the test in person, you have to use ProctorU. So that's pretty much what it comes down to. So now move this assignment back to today so we can talk about it. There's 14 questions. That's not that many questions. Okay. See if there's any on here that I have yet to talk about in the notes. Okay. Okay, let's see how many of these are not in my notes. So I think I went through a good deal of these already. problem 1 is problem 1. So I did that one. Problem 2, I didn't do one with a 4th power, it looks like. Oh wait, I did. I'm sorry. I did. But this one's AC method. I might do problem 2 in a second. Let's hang on to that. That's the exact same problem. I did this one for problem 3. So 4 and 5 are similar, and 6. I might go back to this one. I did 7 for problem 5. And it's the same, almost the same. In fact, I just did this one in the workbook. So just did that one in the workbook. So this one is number 7. This one here is number 4. Number 11 is 6 here. The negative exponents I did for number 8. Well, I think we have a good one here. I think I'm going to pick this one. Let me see the last one. Okay, I know which two I'm doing now. Doing the last 2. Okay, cool. Yeah, they definitely look foreign. So, all right, cool. So I'll do 13 and 14 from the homework, definitely. Cool. So I had open. I'll just start over and oops. This is number 13 from the homework. Eight x to the 2 over 3 minus 39 x to the 1 over 3 minus 5 is equal to 0. There we go. All right, so from here, remember this is the substitution method section. So naturally, we want to find an appropriate substitution. So generally, the middle variable gives us an idea of what the u will be. And this extends nicely. So this is just, if you like the derivation aspect of it, u squared would be x to the 1 over 3 squared, which is x to the 2 over 3. That is exactly this term over here. So u and u squared do fit perfectly in. So once we do that, we're just copying down, but now u to the 2 over 3 is u squared, or x to the 2 over 3 is u squared, minus 39u minus 5 is equal to 0. And from here, it's using the AC method. It's off to the side. It's 8 times negative 5, which is 40, or negative 40 rather. That's to multiply to give negative 40 and add to give us negative 39. I'm seeing negative 40 and positive 1 for that. This is just using the AC method. And then from here, This tells us that we can replace negative 39u with negative 40u, that's the first one, plus 1u, so this one. And then minus 5 is equal to 0. And with the AC method, now we have 4 terms. You factor by grouping. So here's a group, here's a group. The first one, they have 8u in common. You can take out an 8 and a u. So then you are left with a single u. 40 divided by 8, that's 5. And then it turns out we don't even have to factor anything out of the second one. There's just nothing to factor out. We already have the pattern. Or if it makes you feel any better, we're factoring out a 1, if you want something to put there. But really, in essence, we're not factoring out anything. And then from here, we see the pattern. So we know what to factor out. And once we factor that out, we're left with 8u plus 1 is equal to 0. So now we can split up this factorization. U minus 5 is equal to 0. 8u plus 1 is equal to 0. U is 5, and u is negative 1 over 8. You could have also used the quadratic formula if you wanted to for this whole problem. And you would have also obtained 5 and negative 1 over 8. So from here, we have u values, but we don't have x values. So that means the rule that we established, we need to bring that back. So one of the u values is 5. The other one is negative 1 over 8. Now the question is, to get x by itself, you need to get rid of that 1 over 3 power. Then you think, well, what is a 1 over 3 power? A 1 over 3 power is the same thing as a third root. It's the same thing as a third root. So that tells you to get rid of a 1 over 3 power, you have to apply the third root to both sides. This is the same thing as the third root of x. So 5 to the third power is, I believe, 125. And then we just get x. So same thing over here. Well, that's interesting. We have a third root outputting a negative. So what does that mean? What What's that?
Isn't it still okay?
Yeah, it's still okay. Yeah, so that's okay. So we keep going with this one because third roots, fifth roots, the odd roots, they're not picky. If it were a square root, we could just stop right there and say no solutions on that end. Instead, we actually have to do stuff. So to get rid of a third root, we need to apply a third power. Then we get x is equal to -1/8 to the third power. Well, 8 to the third power is 512. So this is going to be -1/512. Or if you do it in your calculator and you know how to convert from decimal to fraction, you would also get -1/512. That is what you would do for this problem. Does anyone have any questions about this one? Because if not, there's another problem that looked a little tricky. It's the last problem on the homework. This one's number 14. Now this one's tricky because what in the world does this have to do with U substitution? Well, the answer is quite a bit. And there's really several ways you could do this problem. The way I want us to look at this problem is, well, of course, a U substitution. You might think, what in the world is the U substitution? And it might make more sense about what the U substitution is if I simply rewrite the above expression and make one tiny adjustment. Oops, I forgot the script. So this is the same exact thing. This means the same exact thing. You can bring the 2 out or have the 2 in the numerator. It still means you're multiplying -2 times that. And now it makes it clear what the pattern is. So the pattern is, of course, V divided by V plus 3. So that is what we will let U equal. That is the repetition here. And by replacing that, for all instances of that, with U, what we end up obtaining is now U squared minus 2U is equal to 8. So it cleans up very nicely. U squared minus 2U minus 8 is equal to 0. We can go ahead and factor that. Plus 2 times -4 is -8, and their sum is -2. So in other words, is equal to -2 and +4. However, so u's are not good enough. We need to convert back to x's, which means we need to bring back the rule. And apply that rule to the instances of u that we found. So -2 is equal to v over v plus 3, and 4 is equal to v over v plus 3. In both instances, we will cross multiply. So it's a pretty neat feature. All right, cool. All right, so in both cases, we're going to cross multiply. And then you would get -2 times v plus 3 is equal to v. Then the other one, 4 times v plus 3 is equal to v. We can go ahead and distribute right quick. -2v minus 6 is equal to v, and then 4v plus 12 is equal to v. For here, we can add 2v on both sides. And we would get that v is -2. And then on the right-hand side over here, subtract v on both sides. Subtract 12, divide by 3, and then we get that v is -4. So I think it's a good thing I did that problem. That one's pretty tricky. Does anyone have any questions up to here? If so, I think everything I've done has covered everything I can think of. You have additional questions? I'm just going to call it a day here. If you have any additional questions, I'll definitely hang around. But yeah, I feel like I've explained everything appropriately. So this homework on substitution is due tonight. There's something you're tripped up on, please look at my lecture video, because I feel like I've covered one of everything at this point. And other than that, please hurry up and sign up for the ProctorU stuff. If you're taking it in person, you don't have to do anything. Just wait for my word. But yeah, other than that, that's all I got. Have a good day.